Hello and welcome to yet another video. And today we have a B350 Mortar from MSI. And in this case, interestingly enough, the seller already told me what is wrong with this board. So there's a burnt component, the seller told me, to the right of the RAM slots. So let's go under the microscope and investigate that. So there's no boot on this board, and probably has a short on one of the power rails. But let's look at that in detail. And this is what the previous owner was able to spot. This, I think, is either VPP. Yeah, this must be VPP. VPPM. So 2.5 volts, I think, supply for the DDR slots. Sometimes it's located right here, but this isn't it, because this is probably connected to these MOSFETs and VDDIO. So the 1.2 volts for the DDR is probably created here. So this mostly leaves us with 2.5 volts VPPM that should be created by this buck converter right here. And I've seen a similar chip like this blow multiple times before. So this isn't the first, definitely. But let's have a look at the board view and just confirm my suspicion that this is VPPM. So now we are in the board view. And let's have a look. Our board component is U23 right here. This is an MP2147, and this is VPP, just like I thought, yeah. So our VPP, our 2.5 volts are missing. This actually blows up pretty drastically because it actually has a 5-volt supply that goes into there. Yeah, it comes from a 5-volt supply, so that's why it can burn up so drastically. So what we need to do is, first we will remove this this controller, and then see if we still have a short circuit after that, and see how the board will react then if we get any signs of life out of the board. So one of the big problems obviously here is that we're directly close to our DDR sockets when we would try to desolder this. So looking at the backside of the board, there's nothing here. So what we can try in this case is to heat this up from the bottom and try to remove it like that. But what I want to do first is I want to see if this thing is actually still in one piece or not, and see if I can apply some leaded solder to any of the pads around it, and maybe even break it apart already, so it will be easier to remove. So let's try that first. So we get some flux, and now let's see if we can apply some solder. Oh yeah, and part of the chip already just removed. Okay, so we won't be able to just remove it with the soldering iron, and I cannot get to that very close point here. So what we are going to do is I will be heating this up from the bottom with my hot air station, and we will be trying to remove it like that, so without melting any of the plastic connectors. So I will now be going with about 420 degrees of heat. I will first try to preheat the board a little bit from the bottom, and then direct it more at the point where we need to be. We will need a little bit higher of airflow and temperature, because heating up from the bottom, this is a multi-layer PCB, it will take quite some time until it will have heated up enough. So this will probably take quite some while. I will be speeding up the process in the post view, and see you as soon as we will be able to remove this component. And there it is. It partially removed. As you can see, it fell apart. Let's go, while it's hot, let's go over that with our soldering iron and clean this up a little bit and see what is left here. So it looks to me that our center pad is actually burned here. Let's clean the burnt flux up and let's get a good view of what we have here. So right now, having a closer look at this area, and we do have quite some burn in. This part removed cleanly, but I'm not too sure. Is this just part of the chip that is left? Is this charring? It's hard to tell. I think there's part of the chip still. Yeah. Oh. Okay, the track. This track wants to go. Okay, but this is fine. We can still use that. But it seems to be that this is still part of the chip. So we will have to heat up a little bit more and try to remove that, because this seems to be the section that has actually burned in there. So let's get the soldering iron and see if we can heat this spot here up enough and scrape it away. So I'm trying to get a big blob of solder onto my tip. Oh, I think we got it. I think it's removed. Let's get some solder wick, get some flux onto the solder wick and try to clean up the pads. So now let's clean up again with a cotton bud. And let's assess the situation that we have right now. So let's have a closer look. So these three pads are fine, these two are fine. This one is twisted, but it is still there. And then you have this one that is basically completely burned up. This track here. And then you have that one. This is, I think, the ground. This one is probably the output that is actually burned here. Very interesting. So let's check this area for some short circuits, if any shorts are left. So, seeing the multimeter, let's see now. Let's say we have 1.3 kilo ohms, and this should be ground, I think. This should be 0, yes. So the output now has high resistance. Let's check the input. The input also seems to have high resistance. So this is the 5 volt input. This is the 2.5 volt output. This is the ground plane. And this burn track is our output. And yeah, so the only thing I'm worrying about is the actual output, because you can see the track is all the way burned. And what is left of that is this part here. That is left from the output. So while trying to get the pad straight, the tip of it broke off. So we have this left of it. And there's nothing also left from this except this part. So what we can do now is we can see if the board actually turns on now and supply our own VPP voltage to it in order to replace that power rail, just to see if the board already works with that. So let's try that. So while building the board up, I also have noticed this. So there's a missing capacitor here. This might be necessary for boot up, but let's keep that in mind. Let's not do anything about that for now, But let's keep in mind that there definitely is physical damage also on this board. Cannot see anything else right from the get-go. Not going to search for it anymore, but this capacitor. But let's keep that in mind and let's build the board up. So let's now have a look. We're going to turn this on. The passive power consumption is very low. Very, very low, to be honest. Let's get a power button into here and a speaker. Let's press the power button. And there's no reaction to the power button. So there seems to be more wrong with this board. Because pushing the power button, nothing happens. So we will have to take a look closer at the areas where there might be knocked off components. So we will have to look at the SIO area and also at the area close to the power button if there's any knocked off components. So looking at the power button area, our pins are a little bit bent, but I can't seem to see any physical damage. Board is very dirty, but the area seems to be fine. Let's have a closer look at our SIO here and stuff around it, just to be sure that there isn't anything damaged here that would prevent this board from reading the power button and starting up. So also looking under the PCIe latch, but it seems to be that there's no damage to the SIO or close to the SIO area as of now. There's just a little bit of grime here. This should be the supply, I think, for the SIO. Let's check the resistance around the SIO. So checking random capacitors. Just seeing if we get any signs of shorts. Yep, and none of these seem shorted, so we should be fine on that. Let's continue our search. So I found something on the back. Someone has been trying to work on this board. So we got to clean this up. This looks like someone tried to remove a capacitor from here. And he was trying to get these holes cleared out, but wasn't able to. Like, for someone who's never soldered before, this is basically impossible to remove. Out of a multi-layer PCB, remove these electrolytic capacitors. So we will now have to clean this area up here, just to be sure that we know what is happening here. So this area actually looks annihilated, and I saw that there's a capacitor lower right here that has been somewhat successfully removed. So let's also clean this area up and see if there's any damage left. So this area doesn't look as bad compared to the top section of it. Compared to this section where they were not able to remove the capacitor. I cannot see any similar areas as of now. Let's check one other thing. Okay, no physical damage here. This board looks like it also has been water damaged, to be perfectly honest. So this board has a lot going for it. Especially because it's only B350 board. I can see some more scratch marks here. But they don't seem to be too deep. Some are here. So just to be sure, let's remove these blobs of solder here. And then we will have to take a look at the front side and see where these capacitors should be and what they are responsible for. So we're not going to use any braid. We're going to be using a solder sucker for this. So let's get our soldering iron. Get some leaded solder into here so that we have a lower melting point. So get this nice and flowing. And that hole is clear. So let's apply, let it solder to the top one. So, and this is the hole basically mostly cleared out. There's still some solder stuck left, but I think it's on the other side and I cannot get to it. So we will have to take a look at the other side of the board and see what kind of carnage was left over there. Another big thing is all of these tracks that go here. These might be PCIe signals, but I'm not too sure. These might be also other signaling stuff. And also there's like random blobs of solder on some of the points here. So we need to be careful of that as well. So let's have a look what this person has been cooking on the other side. But before we do that, let's quickly also clean these up. Because this looks like the capacitor has just been ripped out of here and not actually desoldered. So let's quickly unsolder this here cleanly. And with that, our holes are also clear here. So this is the place where the capacitors have been removed, this and here. And the top side looks fine, luckily. So there doesn't seem to be any damage done here. So with all of that, let's now go a little bit more methodically onto this issue. Let's get some closer measurements in here. So what we will be testing first is the power at the power button, if there's 3.3 volts present there or not. So let's turn this on and let's see at the power button. We have 3.3 volts actually. Okay. But we have no reaction to the power button then afterwards. Let's see for the 5 VSB. This is also present. Let's check the supply voltage for the SIO. This is not for the SIO, this is something else. Let's see. This is the PCH, I think. So if this is the PCH, then we don't have any activity on the PCH. And that might be a problem. Yeah, the 3.3 volts for the SIO is present, but we might not have our 1.05 volts that we need for the PCH right here on this coil. So let's have a look at the board view if that is actually our 1.05 volt rail. So now on our board view, it's this one here, and yes, this is our 1.05. And this is from standby, also 1.05. Interesting. But I would expect this to be present from the beginning on. This takes 12 volts. The enable signal comes from here. So this might not be actually our standby supply, but our standby supply is probably this one here. So this one going there and then here. This is probably our standby supply. And this is the supply that turns on as soon as there is power actually going into the board. Because the input seems to be this 12 volts here. And this 12 volts only comes in as soon as the board is actually starting up. And having 12 volts coming like from the ATX. So yeah. So this is not faulty, I'm pretty sure. This is supposed to be turning on later. And in standby it is supplied by this here. So let us check on the board view now, where our power button is being read from. And here we have two signals that we need. We have power button and power button. So we have twice power button in. One is the output and one is the input. And let's check both of these. So this one is connected to this 0 ohm right here, and this is not populated. No, this is populated, so it goes to here, And then let's also check where, and this also goes to a resistor right there for 3 VSB. So let's check if we have voltage on, let's say, this resistor here. So we should have on this resistor right here, should have 3.3 volts, and we do. And on that side we also have 3.3 volts. And if we now we need to press the power button and see if this reacts, and the signal actually goes low. So this works. As soon as we press the power button, the signal goes low. So that is fine. And let's now see for the side of the PCH. So we right now need to probe that resistor and that capacitor right there, the smaller ones. And this is quite hard, so I won't be showing that, but I will tell you the result of what I got, because right now I'm holding the board in a really weird angle to be able to show you what we will be measuring. So looking at the multimeter right now, pushing the power button, this also goes low. So this is also present right here. So the power button actually goes out to the PCH. So I've been searching around the board a little bit more, and I was supplying PS on, so forcing the power supply to turn on, and something around this area was getting very hot. And when probing this capacitor right here, we see 0 ohms on one side and almost 0 ohms on the other side. But this isn't on all of the capacitors. So some of them have very low resistance on two sides. So let's see on the board view what this is responsible for, and this might be putting a fault on our board still. So looking at the board view, this is responsible for the 1.8 volt output, and we've measured a very low resistance on this enable pin, and this enable is coming from this transistor here. Very interesting. So I want to be putting in some voltage into here, into this enable signal, and see if, what gets hot here and how much power it takes. So it seems like I've found another problem with the 1.8 volts. So at our power supply, we now have 1.8 volts connected to these tweezers. And if we now, with the phone, go over the area and supply 1.8 volts, you can see 105 degrees, 106. This regulator is just burning up and dying. So the 1.8 volt regulator is also dead on this board. And I'm slowly suspecting that this board had some very catastrophic failure on it. But let's try to remove that regulator and move on from there. And now we have the regulator removed. Let's clean up the area, and then I will try again on the 1.8 volt phase to see how the board will react if we still have a way too high power draw there. So I will now be injecting voltage again into the 1.8 volts, and let's see if anything blows up. And now there's no power draw anymore. Now we only have like 30 milliamps. So this is now fine. Let's see if the board now wants to react to a power button. And we still have no reaction to the power button. Let's see, I don't know if this 1.8 volt phase is a standby voltage or not. But it doesn't seem to be necessary, because we still have no further reaction. And with the help of a thermal camera, I was able to find another short circuit, which is also here, which is also for 1.8 volts CPU. So I will show you that on the board view as well. So this is the inductor that we propped, and this is CPU 1.8 volts, and we are short circuited there. So let's inject voltage into there and see what gets hot. Let's see if it is yet again the regulator that is right by it. So let's see. And yep, that controller is also dead. Let's show you it like this again. This heats up very quickly. 100 degrees, almost instant. We have like 5 amps of power draw. So yeah, we will have to remove that one as well. So the buck converter is now removed, and let's go on to the output. Now we seem to have high resistance. Well, it's higher, it's not high, but it's higher. The board is still warm, I just removed it. So I will be injecting voltage again and seeing if there's still too big of a draw. 110 milliamps. That might be fine. And now, let's see. We will be turning it on. And we will need to supply 1.8 volts to exactly that point where that regulator should be. And let's press the power button. And we have reaction to the power button. We actually go to the CPU LED. And I'm pretty sure we're now missing the 1.8 volts that is supposed to be right there. So let's now get another way of inputting 1.8 volts also into there. And currently we can see that our DDR phase also is blowing up. We have 100 degrees on these MOSFETs. So these MOSFETs here were getting insanely hot. And let's look at the board view. These MOSFET have the DDR output here. So let's check if we have a short circuit here. So on pin 1 of that chip here, we should have the DDR input. And it seems to be high-ish. So we have 170 ohms. Let's see. I want to inject 1.2 volts into there and want to see if anything gets, if there's a big power draw or not. There's just 50 milliamps. Okay, so I don't think the actual phase is shorted. It might be something bad with our MOSFETs. So let's go to our multimeter and let's check the MOSFETs themselves. 120 ohms, okay, to gate. And to gate it also doesn't seem short. Let's check on this side. This seems to even have higher resistance. So I don't quite know why these are heating up so much. Because checking to ground, these have good resistance. And this is ground, so this should be that low. So I really don't know why these were heating up so drastically. What I want to do, I want to remove this coil here and see if these still get as hot as they did. So let me quickly remove that big inductor. And then we will see how the board will react after that. So the DDR phase is also now unsoldered, or at least the inductor. And now I want to see if I supply 1.8 volts again to our 1.8 phase that is missing here. Let's turn it on. We still have reaction to the power button. And let's see if these MOSFETs are still burning up. And the MOSFETs are not heating up anymore. Okay, so we will go step by step, and next will be supplying our own 1.2 volts to these, and we'll be seeing if that has any reaction. And right now we have two LEDs. We have a CPU LED and a RAM LED, and I just cannot hold. I'm already putting in 1.8 volts into two places right now. The CPU was getting warm, so what we're missing now is 1.2 volts for the DDR and 2.5 volts for VPP. Oh, this is so stressful. The big problem is I don't think I have these regulators in stock, and I cannot supply that many regulators into here. I will check if I have some, and maybe free up at least one hand, and let's see from there on. So I've spent quite some time on this board now, off screen, and I want to show you something. Pay real close attention to this, to the power draw and to the LEDs. So I will have to do a little bit of a setup, but this should be interesting at least. So have a look at this. We're starting the board up, and look at this now. We have resetting CPU, and there's a post screen. The board is actually on and posting. Cannot believe that. So I will have to shut it down just to prove that this is actually working. Let's try to get this into Windows. This might be very difficult because I will show you the setup, what I needed to do to actually get this far. So this is the post screen now, and I don't have a keyboard attached. Okay, I will need a keyboard also. Let's get the post screen a little bit bigger for you and move this to the side. So there's the post screen, and there's going into Windows. And there's Windows. It actually reacts. And as soon as I let my probe go, my tweezers that I have in my left hand, this will freeze. And it's dead. So let me show you what I had to come up with in order to get this board to work. Let's get the post screen out of here again. So what I had to do is, there's something weird with the DDR. The board is reacting to the power button right now, but look at the voltage that we have on the DDR. We have like 0.3 volts. 1.3 volts. This is way too high. Like, this should be lower for VDD IO, but it is how it is. One more thing that I had to do, you saw the 1.8 volt regulator that was shorted beneath the CPU that we've removed, and I don't have a replacement for that. So what I did is take this tweezers and inject 1.8 volts into there. As you can see, now it's 1.28. Now it's a little bit better. But the problem is the face is still burning hot. I don't know why, but these MOSFETs are getting very hot just with a single stick of RAM in there. So something about the RAM face is still weird. The board has posted by now. I will take everything off. And another thing that I did was to add this thing here. This is a buck converter, taking the 12 volts of my power supply, of the server style power supply from here, and it's supplying 2.5 volts into the VPP phase right here. Let me show you that under the microscope. So this is what I've done. This is a positive wire connected to the VPP phase, so 2.5 volts, and this is the negative wire going to ground. What I've also done is to solder on a new buck converter here. I found one in my stash of donor boards. I found one of them, and I was able to solder this one on, and this now supplies the 1.8 volts standby. And what I was doing here is I was supplying 1.8 volts to that capacitor right there. And this is not the standby 1.8 volts anymore, but the actual 1.8 volts. And this chip is nowhere to be found online except from Monolithic Power Systems itself. It's a MP5077. And that one is only able to be bought by on their own site, so not even on AliExpress. And that's the janky way how we got this board to work. What I also did is I've put this coil on the other side of the board, so I was easier able to probe it. So there's just a coil hanging off of the other side of the board, but that shouldn't really matter because it does work like that. So just to show you, this is just a little buck converter that I have that takes 12 volts and puts it out into here. And this thing right here is the same thing, just in a 3D printed enclosure with a potentiometer that is easier to turn by hand compared to this one where you need to turn a screw. So this is as far as I want to go with this board. Now this I really can't tell what happened to this board. 1.8 volt phase blew up. Another 1.84 volt phase blew up. One standby, one in turned on condition. VPP blowing up. And something weird happening with the DDR also, where the MOSFETs are getting way too hot under load. I cannot tell you how this happens to a board like this. Like, seriously, this is so weird. Like, the methods I had to use to get this to boot with... Okay, this was fine. This was just another one soldered on. This was just supplying 1.8 volts. But as soon as you need to input more than two different voltages, my single output power supply gets to its limits. So we were able to put in VPP because that also blew up. And the DDR, I don't know why it behaves so weirdly. But the board is theoretically in a working state, because we've removed all of the bad components and all we need are 2 controllers right now. And maybe looking into the DDR phase, looking what is wrong with that. But yeah, cannot believe how much time this took me to figure this out. Oh yeah, you would also probably need to provide these 2 capacitors that are here. And also clean the board up with all of what has happened to this. Because, yeah, there's been quite something done to this board before. But we got it working. Even though it's not in a functional state for using in a PC, the most important thing for me was to learn what was wrong with it and prove the fault and be able to get it into a theoretical working state. Like you saw, this booted into Windows without any problems when I was supplying the voltages manually. So, I hope you learned something. I hope you enjoyed this video. Don't take this too serious. Take this more for entertainment, because, yeah, this is quite... this is not the way to actually fix a board, but to prove a fault. So, thank you very much for watching. Like and subscribe. This was Mainboard Medic. Thank you very much, and goodbye.